We're going to analyze and graph the rational function in example 1c from notes 4.2 day 1. To begin, we're going to factor the rational function. The denominator is a perfect square trinomial that factors as x minus 4 quantity squared. To find the x-intercept, we're going to let the numerator equal to 0. We're going to find x values that make the numerator 0 and the denominator not 0. In this case, there are none because 3 is never equal to 0. Let's go on to the y-intercept. To find the y-intercept, we're going to let x be 0. So we're going to evaluate the function f of 0. So that is 3 over 16. So the y-intercept is the order pair 0, 3/16. To find vertical asymptotes, we're going to look for values that make the denominator 0, but the numerator not equal to 0, or if there's common factors, we're going to look for values that can't be factored out of the denominator. In this case, we have a vertical asymptote when x equals 4 from this factor x minus 4, and it has even multiplicity because we have x minus 4 squared. That factor of x minus 4 occurs twice, which is an even number. Holes occur when we have common factors between the numerator and the denominator. In this case, we have none. There's no common factors. And then in terms of the infinite asymptote, we're going to look for values. We're going to compare the degree of the numerator and the denominator to determine what type of asymptote we have, an infinite asymptote that we have. The degree of the numerator, in this case, is 0 because we have a constant term. That's like 3 times x to the 0th. The degree of the denominator is 2. N is less than d. If the degree of the numerator is less than the degree of the denominator, our graph is bottom heavy, we can say. So we have a horizontal asymptote at y equals 0. We will not have a slant asymptote. We can't have both a horizontal and slant asymptote in a single graph. And we'd like to know, does our graph intersect the horizontal asymptote? To determine that, we would set our function 3 over x squared minus 8x plus 16 equal to 0. We'd find that 3, we'd be looking for 1, 3 equals 0, which has no solution. And in this case, since we have no x-intercepts, we also know that our graph is never going to intersect the horizontal asymptote at y equals 0, so we really don't even need to do that analysis. To graph our function, we're going to put on any points we know. There are no x-intercepts. We do have a y-intercept at 0, 3/16, so I'll plot that in the graph. And we'll put on our asymptotes. So we have a vertical asymptote at x equals 4. So I'll sketch that in using a dashed line. So x equals 4. I'll put a little e at the top to denote that it has even multiplicity. We have no holes, and we have our horizontal asymptote, which I will put in at y equals 0. Okay, and now we're going to try to sketch our graph. The graph has to pass through the y-intercept. We know that the graph is not going to cross the line y equals 0, so our graph has to be staying above the horizontal asymptote at y equals 0, pass through the y-intercept, and then as it approaches the vertical asymptote at x equals 4, it's going to shoot up to positive infinity. When our graph goes across to the opposite side or to the positive side of x equals 4, we know this is a vertical asymptote with even multiplicity. So the graph is not going to go across the x-axis. Instead, the ends are going to stay together, and our graph will be shooting up on both sides of the line x equals 4, and then it's going to approach the horizontal asymptote as x goes to positive infinity.